Good afternoon. Welcome to today's webinar entitled Debugging MEMS Process Flows with Physical Simulations, hosted by NNIN at University of Michigan. Our presenter for today's webinar is Mr. Thomas Hall from Intellisense Corporation. Tom is the Sales and Application Manager at Intellisense. He has a wealth of experience in MEMS design, CAD, FE simulation, customer education, and training. He has been an integral part of the Intellisense team by fostering healthy business relationships and by keeping prospective and current users informed about the latest software developments from Intellisense. Tom has a degree in mechanical engineering from Boston University. And without further ado, over to you, Tom.
Thank you for the introduction. And first, I'd like to thank the NNIN at Michigan for hosting this webinar and inviting us to talk. The topic of this webinar will be debugging your MEMS process flows with physical simulation. And to do so, I'll be demonstrating some of the tools available through IntelliSuite. Basic outline of what I'll be covering today. I'll start out by discussing the basic design flow options you have, the major approaches that are available when you're designing your MEMS device using IntelliSuite. I'll touch upon our behavioral modeling tools, our fast field solvers like TEM, and then we'll go more in depth with physical design and geometric modeling and process validation. And then at the end, I'll say a few words about our support for popular PDKs that are available nowadays. So first, before you even start debugging your process flow, during your design phase, there are two major approaches that you can take. So there's the top-down approach, in which you have a structural description or a schematic layout of your MEMS device along with your process flow information. And from here, using a tool like Simple, our system-level analysis tool, the topic of the previous webinar we gave, you can synthesize your mask layout or mesh a 3D model for analysis in one of our FEA tools. There's also the bottom-up approach, in which you already have your mask set that you can design in a layout tool like Blueprint and your process flow information from IntelliFab. And from there, you can generate your 3D model for use in one of the multiphysics modules or in one of the visualization tools like FabViewer or FabSim, which we'll be covering more later. In IntelliSuite, we try to mix both of these approaches. So if you have your process flow information already built up, you can, in some ways, unlock all of the power of all of the modules and make everything work together in your benefit accurately and quickly. So first, just a few words about our behavioral modeling tool called Simple. With Simple, you can generate your device using a schematic layout, and for each of the elements in the layout, you can define your particular characteristics, such as material, size, and you can analyze the behavior using one of the graphing tools that are available with Simple. From Simple, you can also directly export to a mask layout in Blueprint and add certain details like stress relief curves and dimples. You can also directly generate a 3D meshed model using Mesh Manipulator and 3D Builder. And again, there's attention to detail with the dimples and anchors. But first, you'll want to generate your mask layout using a layout editor like Blueprint. And within Blueprint, we have several drawing tools that are tailored specially for MEMS. Here we can see the Simplify tool, which makes it easier to mesh your 3D model that you generate from your mask. and you could also add fillets right from within Blueprint. Another thing you can do within Blueprint is view your cross-section just by drawing your cross-section plane. This is a good preliminary step before you develop your process flow even, just to make sure that you have your layer information correct, you have everything on the correct layer, and it's a good tool just to do a basic sanity check before you get too far in your design process. There's also the design rule check, where you can define certain design rules, and then as you're drawing your layout, you can check it and see if any of the elements in your drawing are violating any of the rules. Next we have our tool 3D Builder. In 3D Builder, you can generate your model into a 3D format directly and then mesh it for TEM analysis. And then along with 3D Builder, there are a variety of meshing tools. The first is called Hexpresso. It's the meshing engine that 3D Builder uses to export your model for FEA analysis. There's also Mesh Manipulator, in which you can generate a 3D model directly from your mask within Blueprint. And from there, you can edit your mesh for different formats, and you can export your 3D model to other 3D formats. For example, if you want to use a tool like SolidWorks, you can export your model into IGS format and open it with other popular CAD tools. Next we have our multiphysics solvers. They're fully coupled for thermal, electrostatic, mechanical, fluidics, contact physics, piezo, and magnostatics. And then we also have two specialized engines for biomems and microfluidics and electromagnetic analysis. Lastly, you can extract the macro model right within TEM for use in Simple. So if your goal is eventually to bring your multiphysics model into a system and analyze the behavior there, you can use these extraction tools. So in our multiphysics tools, we try to use the best solvers for each physics domain, and then fully combine everything for more accurate results. You can also do multi-contact macro model analysis. So here you can analyze the different modes for faces that are making contact. You can also analyze the Seebeck effect results and see how it affects your structure. And then the main focus of this webinar will, of course, be the cleanroom tools. So originally, you'll start out, you'll want to generate your process flow in our process flow simulator IntelliFab. And here, you can group your various process steps into different groups, depending on the process you're performing. And here you can also define all of the specific parameters for each step. And as I'll show you later during the live demo, you have all of the options up here. So you can visualize your process flow using 3 different tools actually: FabViewer, FabSim, and Mesh Manip. You can export to thermo-electromechanical for FEA analysis. You can go back to your mask layout in Blueprint. So first, I'd like to say a few things about FabViewer. FabViewer is our traditional voxel-based visualizer for your process flow. Within FabViewer, you can take a look directly at the different layers in your process. You can also scale in X, Y, or Z directions to get a better look at your process flow. Within this tool, you can also look at cross sections from any direction, and you can watch the process flow. You can watch the simulation directly while you're looking at a cross section, which can definitely be a good method for debugging your flow. Next, we have some standalone tools that are created for specific processes. For example, IntelliEtch is known for its anisotropic wet etching simulation abilities. With IntelliEtch, you can simulate wet etching at higher order planes, and as you can see here, all of the results are backed up by experimental data. We've put a lot of work into this module over the years, and it's always improving. We've recently developed a GPU version that can perform simulations up to 100 times faster using your graphics processing unit instead of the traditional CPU. And more recently, we've developed a module specifically for lithography processes called Exposure. Within Exposure, you can simulate exposure, post-exposure bake, and development. And what I'll be showing today is FabSim, which is a tool that combines all of these other standalone tools so you can visualize your entire process flow using physical solving methods. So for example, here you can see RIE wetching of silicon within FabSim. And here is an example that shows wet etching. And instead of traditional methods where you would just have a geometric based method, here you can see the etch cavity under here. You're only going to get that accuracy with physical simulation. So for wet etching specifically, it uses a cellular automata method with kinetic Monte Carlo algorithm, the same method used within IntelliEtch. Here's an example from Stanford of a photonics element, and you can see here in these etch cavities the detail that you just wouldn't see with a traditional geometric method, a voxel-based geometrical method. So these are two of the examples that I'll show today. First, we have a structure where we have to account for corner compensation during etching. As we can see here, this corner, we're going to get different results in FabSim because it takes into account more of the etching effects than a voxel-based viewer. Second example, we'll take a look at the lag effect in DRIE etching. On the left, we can see with FabViewer, when it etches, it just goes straight down and leaves clean walls in the etch cavity. In the physical-based simulation, we see more of the effects created by the lag effect. So, without further ado, I will open one of these examples. I guess we can start out with the corner compensation example. So right here, we see you can choose your mask, and here we're using the same mask that you saw in the previous image. If you want to get a closer look or you know exactly what cross-section you want to look at before you even start, you can define your area of interest here. For this, we'll just look at the whole thing. Press OK. And one of the features of IntelliFab that is pretty great, especially if you're working with multiple people on your team, or you're working with your manufacturer and you need to give them information about your process flow, you can export a process flow traveler. So just call this corner. That will open right within Excel. And here you can see everything from your material information to your process parameters for each process step. So I will visualize this process flow within FabSim. And first, I'd just like to give a little overview of the features in FabSim. First, here you can define your resolution settings. So here I'm actually using my the memory from my graphics card. So you can see here I have my available, it's actually VRAM, of about 4 gigabytes. So let's start out with a low resolution. And then run the simulation. And as you can see here, it's the last step is the silicon wet etching step, so it takes a little bit longer than the other steps because it's actually using a physical solving method. So here, if I remove the mask by moving the cross section down there, we can see what the corner part looks like, and this is definitely a different result than what you would see using a voxel-based simulation. Now we can increase the resolution. Let's try high. And it will reload our model. And then when we run again, well, first, take a look at the process table as we run it. So first we see the deposition of the silicon oxide. And then our step using the exposure, and then the etching steps. And as you'll notice, it does take a little bit of time, but you're definitely getting very accurate results for the process flow. If you'd want to get a closer look at a specific step, like one of the etch steps, you can import your mask information into IntelliEtch and get a closer look at the etch step specifically. But even FabSim by itself gives a very good representation of what your final result will look like when you are completed with all of your process steps. We're still waiting on the last step. Another thing I'll mention about FabSim while we're waiting is you can export your process flow visualization as an AVI file for a movie. You can also export a PowerPoint file showing the model at any orientation that you desire, even a cross-section. And these PowerPoint files it will show a slide for each step, and at the end we'll give a legend of all of the steps and all of the material used, and you can fully edit these for presentations and whatnot. You can also export to a variety of different image formats. You can export to a sequence of images all at once, so it will create a folder with all of the process images inside. And the reason this last step is taking a while is because we have it on the higher resolution setting. Generally, if you have your resolution settings on medium, you'll see it go much faster and you'll still have very accurate results. But for this example, it would be good to have a high resolution idea of what the final device will look like. Not really a device, it's just an example. Oh, in the meantime, I'll show some of the features of IntelliFab. So within this corner compensation example, we can go back to our layout tool and take a look at our original mask layout. And so if you find a mistake in your process flow, by looking at the visualization, or you see that the corner compensation didn't work out the way you planned, you can directly edit your mask right from within here, and then save your mask, re-import it to IntelliFab, and then run the visualization again. You can also export for TEM analysis using this button here. There's also this process verification tool that will give you some recommendations for your process. So like in Blueprint, we have our design rule check. This is kind of a fabrication rule check. So it will look for any blatant errors you may have made during fabrication. So here it is, it's finished. So first I'd like to show the front view. The cross-section tool. So as you can see here, you can view the cross-section at any angle actually. If you click here, for example, and if you'd want to, you can rerun the process looking from your cross section. There's also a measurement tool. We have these measurement tools in most of the modules. So here you can click Start Measure and select 2 points. And here it will show the distance in the X, Y, and Z direction. And within this you can also view a solid model that's meshed and then export it in one of these formats and open them in other CAD tools. Alright. Now another example we have is the lag effect example that I was talking about earlier. And here, I actually already have the example open. So if we run it, there are only 4 steps. The etch step in this one actually takes a little bit of time, so I ran it already before we began. And here, if we look at the cross section, we can look at a detailed view of what we might see in the walls of the etch cavity. So with a voxel-based simulator, you would just have straight walls and 90-degree corners. Here, we see definitely a lot more definition. I believe this is a medium resolution, so if we looked at this at a higher resolution, you would see even more detail. And of course, you can scale your view. I have the cross-section tool turned on. And see your cross-sections. One more example I'd like to show is this buried cavity example, in which we have in the center of a structure we have a cavity that is etched out. First I'd like to show it in FabViewer. So here we can see that the cavity is etched, but we don't see much definition there. So if we try again using FabSim, we will see higher accuracy in the cavity itself. So in most cases, when you use the 2 tools, FabViewer does the job for most process flows. When you have processes with higher order wet etching or more complicated steps, FabSim with its physical solving methods will generally give you a better representation of what is really going on. So now the etch processes are taking place. So here, if we look at the cross-section, we get a better representation of the cavity. And of course here, within the cross-section, you can use the measurement tools. You can also look at the orthographic projection of your structure. This could be good for movies that you make or presentations. I think it's safe to assume that you wouldn't want to use that for any of the measurement or anything. And of course your top, bottom, left, right, all the different side views. So as I was saying before, in IntelliFab, you can export to a 3D model that can be used for other 3D CAD tools using Mesh Manip. So this will quickly mesh the structure. It won't show an extreme amount of detail with the part that involved wet etching. But here you can define whether you want each material to be one entity or multiple entities, and you can define your output format, IGS, STP, or Parasolid. And from that 3D model, you can go on to perform FEA analysis using one of our tools like TEM. So here it is. So you can see the etch step didn't get incorporated into the mesh itself. For that, you would want to use the meshing function, the mesh and export function within FabSim. But here, you can scale in the Z direction, just get a better idea of the 3D look of your device, and export to all of these formats. So, as I said in the beginning, I was going to touch upon the process development kit integration in IntelliSuite. Oh, meant this slide here. So we support several commercial PDKs, including the MEMS processes from MEMS-cap, some from Summit, Sandia, and some other PDKs. We're always looking to support more. So I'd like to show you a few of the MEMS processes modeled within using IntelliFab and FabViewer. First, here's the metal MEMS process in FabViewer. The metal MEMS process incorporates three major processes: thick metal electroplating, bulk micromachining and surface micromachining. Metal MUMPS processes are commonly used to make relays, microfluidic devices, and certain RF devices. So this is an example of an animation that you would see out of FabViewer or FabSim. Next, here's the SOI MUMPS process flow. SOI stands for silicon on insulator. And common applications for SOI MUMPS are gyros, certain optical devices, and they're commonly seen in some display technologies. And so with all these PDKs, you'll find that when you're developing your device, it makes the whole process a little more user-friendly if you go with one of these design kits, because there's more standard information about the process flow itself, which makes for easier design and definitely less stressful fabrication. This next one, the piezo MUMPS process, there isn't that much information available about it. It's not completely available yet. But this is just a preview of how we're looking to support it with IntelliFab and our visualizers. And we're currently offering a free copy of FabViewer with a collection packaged right in of the MUMPS process kits, two of them, the metal MUMPS and the SOI MUMPS. So if you're interested in a free copy, feel free to email us at sales@intellisense.com, and we'd be happy to send you the package. And now I'd like to open it up for questions if there are any.
Thank you, Tom. Do we have any questions from the audience? Okay, we have a question. Do you have any module that simulate material properties?
I need to turn my volume up. What was the question again? Sorry.
Do you have a module that simulates material properties?
Yes, we do. So we have a module called MEM material, MEM material, and it's the material database that works within all of the other modules. And within it, you can browse all of the materials we have or add material properties for another material that might not be present in there. And then you can graph, create 2D and 3D graphs comparing all of the material properties for the specific materials. And then that module works closely with IntelliFab, NTEM, and all of the other modules. So when you get IntelliSuite base, which is the basic collection of modules, that's one of the utility modules that comes with it. So it works behind the scenes of the other modules, but you can run it as a standalone tool and get and look up material information or define material information for the materials you want to use in your simulations.
So another question related to material properties is, do you have a module which can simulate a bilayer consisting of two dielectric layers during heating?
I'm not entirely sure about that, but I can look into that. If whoever asked that question could send me an email. My email address is right here at thall@intellisense.com. I will look into it and ask our support team. I don't think that's something that would be done right within the MEM material module, but I can get an answer on that.
Do you have any other questions? Okay, so thank you, Tom, for the presentation, and we apologize for the glitch during the webinar. We'll make sure that it doesn't happen again. To stay updated on more webinars hosted by NNIN on Intellisense and a host of other simulation products, please visit our website. It's lnf.umich.edu/NNIN at Michigan. Thank you, and have a nice day.
Thank you very much for having me. Have a great day.